Hello, learners, and welcome back to Wizartist. Today, we are going to be studying Class 8 Physics, Chapter Friction. So, the first question that comes in your mind when you look at the title or the chapter name is what is friction? In a definition, we can say that friction is a force that opposes the relative motion between two surfaces in contact, and it acts on both the surfaces. Let's have a look at a motion, right? So suppose this is an object and this is a surface. So if the object is moving this way, the friction is going to be in the opposite direction. So wherever there is motion, there is some friction acting, and this friction is always in the opposite direction. What the opposite direction means is that if this is one direction, the opposite direction will be the other side, that is the opposite direction. That is going to be the direction of friction, right? And it acts on both the surfaces. So again, if we look at this system, the frictional force will act also on this surface, the below one, and it will also act on the surface or on the object, okay? Now let's move ahead and see an example. It's similar to what I just explained with annotations in the previous slide. So let's have a look at this simple motion of a truck traveling on a road. So if the direction of motion of this truck is this side, then obviously the friction will be in the opposite direction as shown here. So the frictional force is in the opposite direction. Great. So this is what we just concluded. Frictional force is always opposite to the motion. Here are a few examples. The first one is that of a banana peel. You must have noticed that whenever you walk or accidentally step on a banana peel, you slip. If you've not faced this in real life, you've definitely seen something similar in cartoons, right? And this is because there is less friction between the peel of banana and the floor, which is why your balance gets disturbed and you fall. We'll understand this a bit more ahead. Another motion that we can look at is that of a ball. If you roll a ball, it travels a little distance, and then it stops. Why does it stop? Basically, it stops because of the fact that friction is acting on it. The friction of the surface. So if the ball is moving in this direction, the friction tries to stop it by being opposite. So when the friction overcomes the motion, that means the ball stops. Overcomes means the force of friction becomes more than that of the motion of the ball, right? So any quantity in physics is affected by various factors. A few factors affecting friction are nature of surface, area of contact, and weight of body. First, understanding what nature of surface means and how it affects friction. So let's have a look at an activity first. Let's create a ram of sandpaper first. So we all know that sandpaper is a little rough. And now let's place a toy car and let it fall freely down the ramp. We can notice that the car is pretty slow while it comes down the ramp, and also it doesn't cover a lot of distance. It's only till here. On the other hand, if we take a ramp of smoother material, say marble, and let the car go, it's a lot faster. We just observed it's a lot faster. Also, it travels a lot of distance. So in the previous one, where it was sandpaper, it was only till here, but this time it covered a lot more distance. It's because it is easier to you perform motion on a smooth surface. Why is this? So let's just conclude whatever we just did in the activity. So there were two surfaces, marble and sandpaper. What we saw in the case of a marble ramp is that because it was smooth, the motion was faster and also a more distance was covered. On the other hand, in sandpaper, the surface was rough, it was slower, and it also covered less distance. Therefore, we can say that in marble there was less friction. What do we mean by less friction? It means that there was less force opposing the motion. If less force is opposing the motion, the motion will keep on going on for a long time unopposed. Suppose if you're trying to do any kind of work, if no one is opposing you, everyone is supporting you, you feel very motivated to do that work. You can continue doing that work for a long period of time. Similar is the case of motion. The smooth surface has less friction, and because of less friction, it is smoother, faster, and covers more distance. On the other hand, while doing a work, if a lot of people are like, no, don't do this, if your friends say don't do it, you probably get demotivated and do that work for less time. Similar thing can be applied for friction. Because a rough surface provides more opposition, therefore, it has more friction. Because there is more friction, obviously the motion becomes slower and covers less distance. So, what exactly happens in the case of a rough surface? So this, for example, is a rough surface. If you understand it, zooming it out, we can see that there are certain irregularities. Irregularities means this is something that is regular, like a straight line, and irregular is something like this, which is not a straight line, right? So certain irregularities are present. That is why whenever you touch it, you have a feeling that it's rough compared to a smooth surface. Because of these irregularities, it latches onto the surface of the object, right? So this is the surface where the object is moving, and this is the object, right? Because of the interlocking, we have to apply a lot more force to overcome this interlocking and thus cause the motion. Okay? So therefore, we can say that friction is increased because of this interlocking, and therefore we need more force to cause or continue the motion. The next type of surface we saw was a smooth one. Now, a smooth one has lesser irregularities. Now, over here, it seems like it's a straight line, but even smooth surfaces have minute number of irregularities. Now, in suppose in rough surface, it's something like this. So in smooth surface, it will be something milder like this. Okay, so because there is less interlocking in a smooth surface, less force is required to overcome it. And also, less interlocking means there is less friction. Because interlocking essentially is a big cause for friction itself. The next type of factor is area of contact. First, let us understand area of contact with the help of these three objects. The first one is a toy tower. The second one is a slab of any material. Over here, it's a marble. And the third one is a soccer ball. So in the first one, what area is touching the surface? So this is basically the surface that they're standing on or kept on. So how much area is this tower of toys hovering or touching? So this is the area that is basically being touched by the object. So therefore, this is the area of contact, the yellow highlighted part. In case of the slab, the entire portion is in contact with the surface or is touching the surface. Therefore, the entire thing is area of contact. In the case of a ball, it's only a small point of contact each time, so only this much is the area of contact in case of a ball. So when area of contact is more, that is in the case of the slab, and when less area of contact is there, it is in the case of the ball. Now, if there's less area of contact, it means less area is being contacted as the motion is happening, therefore there is less friction. That's why it's a lot easier to move a rolling ball or to move or roll a ball, basically. On the other hand, for a slab of marble, it's very hard to push it, right? Like, comparatively harder than what you do simply rolling the ball. So therefore, it has more friction. So the amount of friction can basically be judged by how much force you need to move the object. So the moving a ball or a toy tower, for example, is a lot easier compared to the slab of marble. Therefore, the ball and the toy tower has less friction compared to the slab of marble. So, in terms of physics, we can say that the area of contact is directly proportional to friction. So, this symbol means directly proportional. It's not something that's in your portion right now, but it's a good thing to know this. So, what this means is that when area decreases, friction also decreases. Directly proportional means that it decreases. If one quantity decreases, the other also decreases. And if the one quantity, that is area, increases, then the other, that is friction, also increases. Area is increasing, friction is increasing. Area is decreasing, friction is also decreasing. So this was a nice visual to understand how the quantities increase and decrease depending on one another. Now let's understand how weight of a body affects friction. Let's take a rock, for example, and try to pull it. So a rock is basically a type of carpet, the one that you can see over here. And it doesn't take a lot of efforts to pull it. On the other hand, if you increase the weight of the rock by maybe placing any object, for example, a chair over here, and try to pull it, it is a little bit hard. It takes more efforts to pull, right? Why is this? This is basically because when heavy object is there, it faces more friction. And if there is more friction, obviously you need more force or more efforts to cause the motion, which happened with the rug, with the chair. On the other hand, if there is a lighter object, that is simply the rug that we took as an example, it has less friction. And if there is less friction, obviously you need less force to cause the motion or less efforts to pull. In terms of physics, again, weight is directly proportional to friction. If weight decreases, the amount of friction also decreases. If weight increases, the amount of friction also increases. Visually, we can conclude weight is increasing, friction will also increase. Weight is decreasing, friction will also decrease. The next topic is types of frictional force. Frictional force is of four types: static, sliding, rolling, and fluid. Let's understand each one of them one by one. Starting off with static friction. Suppose, let's have a look at this truck at rest. In order to bring it into motion, we need to give it certain force or initial force. Initial force is basically the force you apply to bring an object in rest into motion. It's the first force applied before the object comes in motion. Now, whenever there is force or whenever there is going to be motion, there is also going to be a certain friction. That's why it's not very easy to move any object, right? You need to apply some force, and this force is because you need to oppose certain kind of frictional force present. This frictional force that is present before the motion starts, that is, when the object is in rest, is called static friction. The opposing force or friction on an object in rest, that is, before it comes in motion, is called static frictions. This is a simpler definition. A textbook definition could be framed as the force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. So at the instant an object starts moving is the exact time when the state of the body or the object turns from rest to motion. The next one is sliding friction. So whenever there is motion, there is obviously an opposing force. So the opposing force of motion is simply sliding friction. The force required to keep the object moving with the same speed is a measure of sliding friction. Alright, so basically, whenever an object is moving, it is going to have some opposing force, which is friction. And this friction is called sliding friction because it happens when an object is in motion, or in other words, sliding. Now, to overcome this friction, we need some amount of force. And this force should be enough that the object does not slow down because of the friction and it stays in the same speed. So, in simpler words, we can say sliding friction is basically the friction a body faces when it is in motion. And it is important to overcome sliding friction to keep the body in same speed. So, the opposing force or friction on a moving body trying to bring it to rest is called sliding friction. So, the ultimate purpose of sliding friction is to bring the object to rest. And we don't want this to happen, so we need to keep on applying the motion force so that the body does not come to rest. Now, if we compare static friction to sliding friction, static friction is always greater in value because it is harder to, start a body's motion compared to keeping it in motion. Coming on to rolling friction. Let's have a look at a tire, as you can see here, and its area of contact is very less compared to maybe if you take a slab, it will have a lot of amount of area of contact, and this, on the other hand, is very less area of contact. Because the area of contact is less, it will have less friction, as we studied, right? And because of this, as the friction is less, the motion becomes easier. Therefore, wheels are used in many objects for easy motion as they reduce friction. This reduced friction is called rolling friction. Basically, the type of reduced friction that comes from circular objects that roll, basically. Like you can even consider balls or tires over here. And a few examples of rolling friction is different vehicles like car, bicycle, and also there are luggages with wheels. Have you ever wondered why your trolley bags have wheels on them? Because if you consider the base of a trolley bag, it's a rectangle. And if you put it on the floor directly, it will have a lot of area of contact. And this area of contact will make the friction high in number and it'll be very hard to move it. Instead, if you put wheels on it, the area of contact because of the wheels becomes very less, and therefore it's a lot easier to bring it into motion and move it in different places. Let's come on to fluid friction. First of all, what is fluid? Fluid is anything, any matter that flows. That is, liquids and gases. Alright, now let's have a look at a few examples of motion through fluid, because for friction, you need motion. So the first fluid we'll look at is air. So we can see that there is motion through air of an airplane. In water, you can see there is motion of maybe a submarine or fishes, right? So there is always going to be an opposing motion to both the airplane and the submarine. This opposing motion is fluid friction. Basically, the opposing a force to the motion caused by a fluid like air or water is called fluid friction. Fluids exert force of friction on objects in motion through them like we saw airplanes, submarines, etc. This friction is called fluid friction or drag. So another name for fluid friction is drag. It depends on certain factors like speed of object with respect to fluid. That means that it's not just only the speed of object because fluids also move. So you should also keep in mind the speed of fluid and then compare the speed of the object and the fluid. Shape of the object and nature of fluid. Friction, a necessary evil. Now, what does this mean? Friction is needed for basic functioning, but it is also evil as it reduces efficiency. What does this mean? Let's understand. So let's have a look at a few needs of friction. Friction is very important for grip. Suppose if you look at a glass tumbler that is wet, because it is wet, its friction is reduced, and because of this reduced friction, it becomes slippery and can fall. On the other hand, if you take a steel tumbler, which has more roughness, more friction, it becomes easier to hold that. And because it is easier to hold, that is because of friction. So friction is very important for grip. It gives you surface for grip, like holding tumblers. It's also very important for writing. You must have noticed that if you try to write on a glass window or a glass pane, you cannot do that, right? Because the glass pane offers very less friction. And this very less frictions make it almost impossible to write. On the other hand, if you write on a more coarse surface, like a paper, you can easily write. So friction is also important for writing. It's important for tying shoelaces, walking as well. Like I said in the first example of friction, if there is a banana peel, you slip and fall. But instead, if there was a coarse road, a normal road, you would be easily able to walk on it because friction gives you the necessary important factors for walking. If there is less friction, there is a high chance that you will slip. To summarize it is essential for grip and holding objects. It enables movement and walking, facilitates writing and drawing. aids in starting, stopping, and controlling motion. That is, if you just stop the force on any vehicle moving on the road, the friction will automatically bring it to stop. Also, if you want to make the stopping process, faster, you can also use brakes. You must have noticed the brakes on your cycle. If you've ever noticed, they go on and touch the tire of your cycle. Whenever you apply the brakes, it kind of holds the tires and it creates a frictional force which stops your cycle. And that is the use of friction in stopping motion. It also helps a lot in controlling motion. It helps in fixing and constructing. Imagine if there was no of friction, then you won't be able to fix a nail on a wall. If you've noticed, it's very hard to fix a nail on a smoother surface compared to that of a rough surface. At the end, it's important for producing heat whenever needed. Now, heat is not always necessary, but in cases of matchsticks or electronic lighters, friction is a big help in producing heat. Also, if you just rub your palms together, they produce heat. This is because of the friction between your palms. But there are also certain disadvantages or evils of friction. The first one is the wear and tear that it causes. It also creates unnecessary heat in appliances like a mixer jar, and that causes wastage energy. To summarize, it causes wearing out materials, generation of unnecessary heat, therefore energy wastage in machines, reduced efficiency of mechanical systems. Now, if the energy is wasted in heats, then it reduces the efficiency as well. Difficulty in motion, basically, that's the whole idea of friction. It opposes movement. Therefore, motion becomes hard. It causes noise production in machines. Now, noise in the machines is also caused because of, the friction. Damages to surfaces due to abrasion. Abrasion basically means the damage that is caused whenever you constantly rub a surface. Increased fuel consumption in vehicles. Now, because vehicles have to overcome the force of friction, they need more fuel in order to do that. But there are a few ways to increase friction, that is, increase grip whenever needed. This is to harness the good quality or advantages of friction. The first one is groove shoes. Groove shoes soles provide better grip on the floor, ensuring safe movement. Treaded vehicle tires. Tread patterns on tires improve grip on the ground for cars, trucks, and bulldozers. Then there are brake pads in vehicles. Brake pads create friction with the rim or disc that is shown here. You can see that there is a rim over here to stop the vehicle of bicycles and automobiles. You can also see that certain players of kabaddi or other sports, they just rub soil on their hands and this gives them a better grip on the opponent. Same happens with gymnasts who use coarse substances like chalk powder on their hands to enhance their performance. There's also a way to decrease friction because friction is in some places friction is undesired. So we need to reduce that or decrease that to make the motion smoother and reduce its disadvantages. A common example that we see is when we're playing carom. We sprinkle fine powder on the board, and this allows the smoother movement of the coins and striker. This is because the friction reduces, and therefore the motion can take place more smoothly. We also use oil, grease, or graphite as lubricants in machines. It is applied to form a thin layer that prevents direct rubbing of surfaces, and when there is no direct rubbing or direct contact, it reduces friction. In certain machineries where you cannot use oil as lubricant, an air cushion is used. Basically, there is a small gap left between the machineries where air acts as a cushion or a lubricant, basically. So another example, a common example of lubricants can be oiling door hinges. Oil is poured on door hinges to reduce friction, and therefore you can see that the doors start moving smoothly. So before, sometimes you will see that the doors start creaking, they make weird noise. And then you put a little oil and they stop creaking. This is again because of friction. All of this increases efficiency. Reducing friction to these mediums can improve the efficiency as well as lifespan of machines. This is because it reduces the disadvantages that we saw earlier. There's also a way to decrease fluid friction. We saw fluid friction before, and it is necessary for good movement in fluids, that is, air travel or water travel, to decrease fluid friction is important. So we have special shapes of objects. Objects moving through fluids are given streamlined shapes to minimize friction and energy loss. This special shape comes as an inspiration from nature. Scientists designed these shapes by observing natural examples of creatures that, every day have to travel or move through fluids, like birds or fishes, who have evolved to reduce friction in fluids. An example of the special shape can be that of the airplane design. The shape of an airplane resembles a bird, helping it reduce fluid resistance. There is also vehicle design. All vehicles, such as car, boats, are designed in a streamlined shape that decreases fluid friction. And because fluid friction decreases, they'll have to spend less energy in order to overcome fluid friction, and therefore it improves its efficiency. This certain shape is the streamlined shape that again comes from the inspiration of nature. And that was it for this chapter. I really hope you understood each and every concept. If you have any doubt, don't forget to comment your doubt. Also, do like this video, share it with budding learners, and subscribe the channel. Thank you very much. Bye bye.